So 8.5 WSP number 1, we want to factor out the GCF. What's in common in both? There's definitely an 8 in common in both terms. The multiple of 8, that is. If you say 4, that's not the greatest common factor because 8 is the greatest common factor. So what would be left on the inside? You would have a 8 minus 5AB. So that's the answer to number 1. Let's move on to number 3. Number 3, we have a binomial right there. What's in common in both? If you look at the 6 and the 3, there's definitely the number 3 in both. And there's also letters in both. There's an R in both and there's a T in both. So 3RT is the GCF. So when we go 3RT times what will give us a 6R squared T? What would that be? 2R. And then how about over here? 3RT times what gives us a negative 3RT squared? That'd be a negative or a minus, just 1T. Looks like a plus sign. But that's your answer right there, guys. Let's move on to number 5. Another binomial. What would the GCF be? So I always like to put parentheses and then pull out that GCF. So 8, again, is a GCF. Now, there are no letters in both. Like you have A here, A squared here, you have B squared. You can't pull out an A or a B from both. So it's just 8, the GCF. So if you did pull out an 8 from the 32A squared, what's that? What do you have? 4, and of course, A squared. Now, if you do pull out an 8 from a 24, that would be plus 3. And don't forget about the B squared. And that's it. Now, a good way to be confident that you did find the GCF is to take a look at the inside of the parentheses and see if you could pull out anything else. Oh, 4, 3, I know there's nothing else to pull out from there. But if it would have been like a 4 and a 2, then I could pull out another 2. Right? That's when you know you didn't pull out the GCF to start with. Or if I had a 4 and an 8, then I could still pull out a 4. But right here, the 4 and the 3, there's nothing else to pull out. The A and the B, there's nothing else to pull out. So I'm done with number 5. Let's move on to number 7. Again, we have a binomial. What's in common with 30 and 35? 5. And we also have letters that are in common, right? So what's the GCF? 5 what? 5x? Just x? 5x squared, and that's it? And y's. There's a y also. So once again, guys, the 30 and the 35, yeah, they have the multiple of 5, but right here you have 3 x's, right here you have 2 x's, so the maximum amount of x's you could pull out from both at the same time is x squared. And right here, the y and the y squared, the maximum amount of y's you could pull out from both at the same time is just 1y. Now that we know the GCF, now we could think about the inside of the parentheses. So when I go 5x squared y times what gives me a 30x to the third y, I know it has to be a 6. 5 times 6 is 30. And also an x because x squared times x is x to the third. And I don't need a y because when the y is already there. If I had a y there, it'd be y squared, and that's definitely not y squared. So 6x is what's left on my first term inside of the parentheses. And now for the second term, I want to have a what? 5 times 7 gives me 35. Now this x squared, I don't need to multiply it by any more x's because that's an x squared up there. And this y, I need to multiply it by what? By y to make it the y squared that's above. So I really have a 7y. And ladies and gentlemen, that's it. You're done. That's the factored form of number 7, 5x squared or 5x squared y times 6x plus 7y. Let's move on to number 9. So, what could I pull out of there? 15? Now, if you think 5, you're going to see that you could still pull out something else. So 15 is the GCF. Now, is there letters involved as well? Yeah. How many B's? What's the maximum amount of B's I could pull out of both at the same time? 1b. How about the maximum amount of g's that I could pull out at the same time? 2? How many g's right here? 3. How many g's right here? 3. So I could take all 3 g's and take them out over here. So 15b g to the third is our GCF. And then we could look at the inside and say 15b g to the third times what will give me a 75b squared g to the third. And what would our answer be right there? 5b. Perfect. Because 15 times 5 is 75, and b times b is b squared, and the g to the third is already there. And how about the second term? That would be 4, because 15 times 4 is 60, and that's it, because the bg to the third is right there. If I had any more b's or g's, it wouldn't be bg to the third. I would change it. Moving on to number 11. On number 11, we have 3 terms, and we need to factor out the GCF. So what is the GCF? When we look at the numbers 5, 10, and 25, we know for sure the multiple of 5 is going to come out of there. But is there anything else that I could pull out besides a 5?
X and a Y.
Okay, X, somebody said X and a Y. You have
No.
just X's. There is no Y on the last term, and remember the GCF, it has to come out of all the terms. So anyways, we are going to pull out an X. 5X is the GCF. And what would we have left over on the inside? You have to think 5X times what will get us this 5X to the third Y squared? Okay, for sure, an X squared, and you need that Y squared as well. Okay, and then you go 5X times what will get us a positive 10. All right, let's start with the positive 10. What do I need? A plus 2. And then let's look at I need this X, when I multiply, I need to get an X squared. So what do I need in here? An X. And I also need a Y right here. So I also need to put a Y right there. Does that make sense? Yeah. Now the last term, 5X times what will get us a positive 25X? That's just plus 5. And we're done. Okay, we're done right there. Let's move on. Number 13 is not factoring out the GCF, but you should always try and factor out the GCF. Okay, this worksheet WSP is a little bit more advanced than WSPM. So there are some questions we'll see in a couple of moments that you could factor out maybe an X from all of them, or maybe the number 2 from all of them. But right here, you can't factor out the GCF from all 4 terms. So we're going to jump to our second method of factoring, which is by grouping. So we're going to do step 1, rewrite it. I see some students do just like parentheses like this. I don't recommend that, guys. Let's not be lazy. Let's rewrite it. And on the quiz tomorrow, on factoring by grouping questions, I do want to see your work. If you don't have your work, I can't give you the answer. Okay, I can't give you the points, even if you have the right answer. So I want to see this separation first. That's step 1. Step 2 is where you factor something out of the first group. What's in common in the first group? There's definitely an X. If I did pull out an X, what's left over on the inside? X plus 4. All right, good. And now let's look at the second group, and let's pull out something from the second group. What was that? Bless you. A 2. But we're going to say positive 2. And when we pull out a positive 2, what's left over on the inside? X plus 4 as well, right? Okay, so that's a good thing because this binomial is the same as that binomial. And we're going to be able to take a step back and factor out, this is step 3, pulling out that common binomial in both the first and second group. So I'm going to take the X plus 4 and the X plus 4 and pull it and write it out here in the front. And of course I have these giant parentheses. What's left over on the inside of those giant parentheses? X plus 2. Now of course you want to write it with the right size parentheses. Let's move on to number 15. 15 is fun because a lot of us jump right into factoring by grouping, which is fine, but what method should you try first? Greatest common factor. Is there a greatest common factor in every single term? Yes, there is, right? So what could we pull out? 2. So I'm going to put a 2 out here, and then I'm going to rewrite the inside of my parentheses. And what would that be on the inside? 2b squared minus 6b plus b minus 3. Now, notice I did this on purpose. I left space between it, right? I already separated my first group and my second group within the parenthesis. So what I'm going to do right now is ignore this 2 for a while, and I'm just going to focus in on what's in here. As a matter of fact, when I say focus in, let me actually do that. Let me zoom in and just worry about those 2 groups I have in there. So let's take a look at that first group. I have 1 term, 2 terms in my first group. What could I pull out of there? What's the GCF of that first group? And let me again put the parentheses there. And what's that GCF? 2b, right? So let's put a 2b out here. Now what would be left on the inside? 2b times b would give us the 2b squared, and 2b times negative 3 would give us that negative 6b. So far, so great. Now let's take a look at the second group. What could we pull out? We're going to force out a 1. You can't. There is no GCF, but we're going to force out a 1 just so to see if we could continue factoring by grouping. So when I pull out a positive 1, it doesn't change anything. I'm still going to have this b. I'm still going to have a minus 3. Oh, that looks like a 6. Sorry. B. And as you could see, it's the same exact binomial, right? I have the b minus 3 here, the b minus 3 there. So I'm going to take a step back, and I am going to pull that b minus 3 out here into the front. And if I did pull out that b minus 3, what would be left on the inside of the parentheses? The 2b and the plus 1. So the answer is going to be the b minus 3 and the 2b plus 1. But I can't forget about what? That 2 that I originally pulled out. Now remember, that's really the 2 I pulled out from the start. That just becomes 2 times. So I just need to bring it down, and it's with multiplication, so I just need to write it. Nice and easy. This guy comes down right here. And that is my answer. Let's move on to number 17. 17, this one's even more fun. It's the kind of problem you want to do on a Saturday night. Show up to a party, turn off the music, take out your piece of paper, turn on the lights, tell everybody to gather around, show them how to factor by grouping. No, it's instant popularity if you do that. Seriously. It worked for me when I was in high school. All right. Am I recording all this? I'm still recording. All right. What's the first thing we should try to do? Before separating? Greatest common factor. Is there a greatest common factor I could actually pull out?
2.
Again, 2, right? If I do pull out a 2, what's going to be left on the inside?
3.
Now, you know what? For some reason, I'm not liking this first term to be negative. What do you guys say?
You want it to be negative 2.
I would like it to be a positive, so I could pull out a negative 2, and that would change all the signs. You guys want to go for that?
Yeah.
Sure, why not? Just to make it a little nicer looking. So I want to pull out a negative 2, and on the inside, I will have what left over? Positive 3 MP. If I pull out a negative 2, that'll make it a negative what? 2M. If I pull out a negative 2, what will that be? Instead of a plus 18P, what's it going to be? Minus 9P. And negative 2 times what would give us a negative 12 at the end? Plus 6. Right? Negative 2 times positive 6 will give us that negative 12. Okay, so I factored out the GCF. I decided to make it a negative 2 instead of a 2. That way the first term's positive. I don't know. Maybe that doesn't even help us. I'm sorry. Anyways, let's keep going. On the inside of the parentheses, I have already separated them into 2 groups. So let's focus in on the inside of the parentheses. And in the first group, what could I pull out, if anything? What's the GCF of the first group? M. Okay. What would I have left if I pull out an M? A 3 and a P. And also the -2 or -2. Now how about the second group? Over here in the second group, what could I pull out? Okay, if I pull out a 3, we're going to have opposite signs on the binomial. So it's better to pull out a -3. But let's pretend that I didn't see that right off the bat. Let's pretend that I did say I'm going to pull out a +3, and that would give me a -3p in there and a +2. And then you would be stuck because when you try to factor out this binomial and this binomial, you realize they're not the exact binomials, right? So let's say you pulled out a 3 and you realize, oh, this is positive, this one's negative, this one's negative, this one's positive. I need them to be the same sign. So how could I change these to look like these? By factoring out a -1, right? I could take this -3 and this +2, factor out a -1. So this is what kind of happens. You have a times -1, and what would that become? A -3. So instead of pulling out a 3, it's going to really be a -3. Let me do that. Let me just put a negative right in front of it, and we'll be good. And that will make that a +3p and a -2. And now we really do have the same sign binomials right here and right there. Same exact binomial. +3p, +3p, -2, -2. So we're going to take a step back and pull out that common binomial. And that common binomial is 3p minus 2. And what do I have left on the inside of the parentheses? And -3. And we need that -2 out in the front. So we have -2. And then we have 3p minus 2. And then we have m minus 3. By the way, your answers to this worksheet are not on the back. It's a two-sided worksheet. Your answers are on the back of the notes that I gave you on Tuesday. I know that's random, right? But if you go to the notes from Tuesday, you have the answers to this worksheet, WSP. Moving on to the next odd question. So you have to flip over the paper and you end up with the next odd question 19. And right here, we are solving equations and we are using the zero product property. So this is in factored form. It's really easy to solve because it already says something times something equals 0. So you could take that first something and set it equal to 0. And you could take the second something and set it equal to 0. And what we have here is two simple equations that we could solve. But this one's already done for us. This one over here, you just go plus 32, plus 32. So x does equal 32. So you get two answers for 19, 0 and 32. That's as easy as it gets. Let's move on. Another one that's really easy because it's already factored. You already have something times something equals 0. You don't have to factor. It's already factored for you. So you just split it and solve. Y minus 3, you set that equal to 0. You take the y plus 2, you set that equal to 0. And then you just, oh, I didn't set it equal to 0, sorry. And then you just solve both. So over here, plus 3, y equals positive 3. That's one answer. And then over here, minus 2, y equals negative 2. That's another answer. Easy peasy, lemon squeezy. Simple as popping a pimple in a dimple. 23. Another easy one. Split them and then solve them. So on the left one, subtract 5, rewrite it, 2y equals negative 5. What do we have there? We have 2 times y equals negative 5. You don't want a 2 times. So how do you get rid of the multiplication of 2? Divide by 2, and y equals negative 5 halves, or negative 2.5. I believe they leave it as negative 5 halves. And the other one, plus 4, y equals 4. So 23 was easy. Let's check out 25. So far, all of these have been easy because they're already in factored form. But if you look at 25, this one's the very first one of the odd ones that's not in factored form. Okay? What is factored form? You want something with multiplication. Right here it says something plus something equals 0. We don't want that. We want something times something equals 0. So we could use the zero product property. So let's just ignore the equals 0 for a while. Let's just pretend it's a binomial. And what could I pull out of there? What's the GCF right there? A 2 and a z. If I pull out a 2 and a z, what's going to be left on the first term? Just a z. And then the next one plus 10. Perfect. Okay, so what I've done is factored the left side. So now I'm going to look at the equation again, and remember it's equal to 0. And now I truly do have something times something equals 0. So I could just split them and solve. So there they are split. Let's take a look at the red equation. How do I solve that? I simply divide by 2. And 0 divided by 2 is still 0. So z equals 0. And then you subtract 10 over here. And you have z equals negative 10. Number 27, this one's even more entertaining because it's not even ready to factor yet. You cannot factor this. Remember, the whole purpose of factoring is to get multiplication so you could have something times something equals 0. And right here, you don't even have an equal 0 yet. So we need to first move this guy to the left. We need to get rid of that 27. We need it to be 0. So 27x, I need to take away 27x in order for it to become 0. But what I do to one side, I must do to the other side. And of course, I cannot combine like terms right there. You can't do x squared, take away x's. Those are different. So you're just going to rewrite it. So you will have 9x squared minus 27x equals 0. Are you with me? So that was an additional step right there. You first have to set it equal to 0, and then you factor, and then you split, and then you solve. First set it equal to 0, and then you factor, and then you split, and then you solve. So I've already set it equal to 0. Now I'm going to factor. What could I factor out of there? What's the GCF? A 3x. And what would be left on the inside? 3x minus 9. Perfect. And of course, we still have the equal 0 over here. And now that we do have something times something equals 0, something times something equals 0, we could split them and then solve. So on the left equation, the red one, if I divide by 3 and divide by 3, that'll cancel. X does still equal 0. And on the other one, if I add 9, I will have 3x equals 9. Final step would be to divide by 3, and we get the other answer of x equals 3. Last odd question, 29. So again, right here, we have to set it equal to 0 first. So what do?
You add 21.
Add 21x, Add 21x. Could I actually add 21x with the 14x squared? No, so let's just rewrite it. 14x squared plus 21x. It does equal 0 now because negative 21x and positive 21x is 0. So we first set it equal to 0, and then we do what?
Flip it.
Factor, not flip it. Factor, and then after factoring, split it. Where's it? Where's this flipping coming from? It's factor, split, and solve. Actually, first set it equal to 0, and then you factor, and then you split it, and then you solve. So let's factor out the GCF right here, and that would be what? What's the GCF? 7x. What would be left on the inside? 2x plus 3. And of course, it's still equal to 0. So let's now focus in on splitting it, because zero product property says when you have something times something equals 0, you could split them and then solve. So I've split them. Now let's solve the red equation. Divide by 7, divide by 7. It's still going to be x equals 0. Subtract 3. You will have 2x equals negative 3. Final step. to get rid of that multiplication of 2 in the front, you divide by 2, and you will have x equals, you can't really do that, let's leave it, negative 3 over 2, bless you. So those are your 2 answers. And I'm done, but you're not. You got to do all the even ones. Go for it.